This is the screencast for section 5.3, example 4. We're going to connect differential and integral calculus. We're starting that process. 5.4 is the fundamental theorem of calculus. Fundamental does not mean easy, ladies and gentlemen. But anyway, here is the piece that is going to connect, part of the piece, that is going to connect derivatives and integrals that we're moving into in section 5.4. So remember in section 5.2, yes, back here, when we learned that the integral from a to b of a constant was that constant times b minus a. So b minus a times the constant, distance equals rate times time, kind of. Well, here's a situation where it doesn't have to work with a constant. So we know that from exploration 2, the derivative of the antiderivative from a to x of f of t dt is f of x. Okay, so since the derivative of this, of f of t, is f of x, the antiderivative of f of t then is capital F of x. And then plus c. Don't forget that constant, plus c. Now, we also know that the integral from a to a of f of t dt then would be f of a plus c. The top one. Plug in the top one, plus c. And the integral from a to a from our integral properties is 0. So if we solve for c, c is actually minus f of a, capital F of a, or negative f of a. So now we can take that and look at the integral from a to x of f of t dt, which would then be capital F of x, and then instead of plus c, we could say c is minus f of a. So f of x minus f of a. So here's another subtraction situation. We have the integral of our integrand, plug in x minus plug in a. Or, in a more specific situation, which you will see more often, you'll see f of b minus f of a. So the integral of the integrand, plug in b minus plug in a. Alright, so let's see how that works. So in example 4, we're going to find the integral using antiderivatives. We're going to find the integral from 0 to pi of sine of x dx using this formula, this concept. So first of all, the antiderivative from 0 to pi of sine of x dx is going to be capital F of pi minus capital F of 0. Well, what is capital F? Capital F, the integral of the sine of x, is negative cosine of x. And we can write that, now that we've taken the integral, we can put a bracket after that and write it from 0 to pi. So now that's where this capital F, so negative cosine of first pi, now minus another negative, capital F, which is cosine of 0. So negative cosine of pi is negative 1, and then cosine of 0 is 1. So we have positive 1 plus another 1, which is 2. And I double checked that in my calculator, of course, and I got the right answer. Now you might be asking yourselves, wait a second, where does the constant go? I thought there was a constant. Okay, yeah, kinda. So looking at this step up here, we really have f of pi and then minus f of 0. All right, so let's throw constants in there. What if it's f of pi plus a constant minus f of 0 plus a constant? Okay, so now we have f of pi plus c minus f of 0. Now distribute the negative, minus c. Look what happens to the c's. You can make the generalization right now that when you integrate on a closed interval, so a number to a number, c's will cancel because of this. You'd subtract out their c's. Then I'll try problem number 21. Asks us to find the antiderivative from 0 to 1 of e to the x dx. So I'm just going to do this one straightforward. Not going to mess with all the fancy understanding stuff like we did in example 4. Once you understand this concept, here is what you will be able to do. You will be able to do, well, let's see, e to the x is, the antiderivative of e to the x is e to the x, and we're going to evaluate that from 0 to 1. So that's going to be e to the first minus e to the 0, which is e minus 1, and that's our answer, e minus 1. It is as simple as that. Once you understand this formula and how it works, you can just use it. And then I checked it on my calculator, and I got the right answer.